Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're looking at finding points of intersection of lines, okay? What does that mean? It means when we have two curves, two lines, straight lines, curved lines, anything we want to find the points at which they touch. Now you might be thinking something, that sounds awfully familiar to simultaneous equations. In fact, that is what a simultaneous equation is. A simultaneous equation is the intersection between normally two curves, two lines, something like that. If you have more than two variables, we go up in dimensions. So if we have three variables, an x, a y, and a z, or something like that, then we're looking normally at like the intersection of like planes or like weird 3D curves and things like that. But it's the same principle. If we have two unknown variables, x and y, we want to solve to see where they are equal to each other. That, after all, is the intersection between the lines. It's when they share x and y coordinates. That is what we're doing. We're basically doing simultaneous equations, okay? So this shouldn't be particularly difficult, okay? So actually, let's just have a look at what we've got over here first. Notes, guys. Don't be intimidated, by the way, by the notation. I'm going to explain all of it for you. To find the point or points at which two curves intersect each other, you need to put them in the form y equals f of x and y equals g of x. Okay, so just a little aside there. That literally just means put them in the form y equals blah, 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 and y equals a different blah, 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 okay? So y equals x squared, y equals 3x, y, whatever you want, just some function of x and some other function of x, which is going to normally be different. If f of x and g of x are the same function, then they're just the same line or curve, okay? So they're almost always going to be different. F of x is a function of x, g of x is another function of x. The reason we use g instead of f is because g is the next letter in the alphabet after f. If we want a third function of x, we might use h of x or something like that, okay? f, g, h, right, is the alphabet. So that's all we need to know, okay? G of x is a different function of x. Okay, so once we have that, y equals fx and y equals g of x, we want to solve the equation f of x equals g of x. That means set the x stuff equal, okay? Then we want to solve it. We want to find the value of x for which this equation is satisfied. And then to find the y values, we substitute the x value or values that we have found into either equation. Typically the one that is easier, because why would we want to make this harder for ourselves, okay? So that is all we do. It is very similar to simultaneous equations because this is how you solve a simultaneous equation. This is normal. This is the method of substitution, basically. Okay. So let's just take a look at a question. We want to find the intersections of y equals x squared and y equals x times x squared minus 1. Again, I know the lighting is all funny over here, so I'm going to rewrite it for you. This is y equals x squared and y equals x times x squared minus 1, like this, okay? We want to find when these two curves, each of those is a curve, we want to find where they intersect each other, okay? So we could draw a graph and just eyeball it and go, oh, I think it's about that, or we can actually solve this thing. So nicely for us, these are already, and they usually will be, in the form y equals f of x and y equals g of x, okay? So we're going to set them equal to each other. I'm going to then say that x squared is equal to x times x squared minus 1. Why? Because these are both equal to y, which means if y equals x squared and y equals x times x squared minus 1, then naturally you have to assume or deduce, it's not even an assumption, it's a deduction, that x squared must equal x times x squared minus 1. They must be equal to each other because they're both equal to the same thing, okay? So, now here's one thing as well, okay? The reason why we can set them equal to each other as well is because they share the same y coordinate when they intersect each other. They also share the same x coordinate, okay? So that's another reason why we can set them equal to each other, okay? So guys, let's take a look at this equation. We need to solve this equation. Now you might be really tempted to say, okay, the first step we can do to make this a little bit easier is divide both sides by x. But don't do that. Never divide both sides by an unknown number, okay? Because you might lose solutions. Not always, you will sometimes be all right, but a lot of the time, or at least some of the time, you can lose answers by dividing by x, okay? That is because x might be 0. And if you divide by 0, you mess up the whole equation, don't you? So we have to be really careful. So instead of dividing by x, I think we should expand out the right-hand side. So I'm going to say x squared is equal to x times x squared, which is x cubed, just using index laws. And then expanding like this and then like this, we have x times minus 1. That's going to give us minus x, okay? Now, let's take everything onto the same side. So let's come over here and let's take away an x squared from both sides, okay? I just think that's going to be easier. Our leading term, this is a cubic, isn't it? Our leading term is going to be an x cubed, which is a positive here. We've got a positive, we've got a 1x cubed. I think that's just going to be nicer than taking everything onto the other side. It's also less work because we only have to move one thing to the right instead of two things to the left. So I'm going to take the x squared away from both sides. And I'm going to get x cubed minus x squared minus x equals 0, okay? So I snuck the x cubed in the middle, but that's just because now they're all in sort of decreasing powers of x. It's just a bit nicer, okay? Now we can factorize an x back out, okay? So let's come over here. There is an x in all of these, at least one x. So I can say x times x squared minus x minus 1 equals 0, can't I? Because this has just been factorized to this, okay? Now, you technically can factorize this guy, but I wouldn't recommend it because it's actually a really funny number. You can't do it mentally, really. You would need to use the quadratic formula to solve this. So this is two things multiplying together. Either x needs to equal 0 or x squared minus x minus 1 needs to equal 0. So what I would say is I would set up the equation x equals 0. That's just done, that's fine. Or, I should say, x squared minus x minus 1 equals 0. And now we do need to use a calculator or just the sort of quadratic formula by hand to work out what this is, okay? So this is one of our solutions, x is equal to 0. That is why we shouldn't have divided. If we divided by x, by the way, this solution, we wouldn't be able to find it. So don't divide by x. Putting in our numbers into the quadratic formula, we end up with x equals 1 plus the square root of 5, all divided by 2, and x equals 1 minus the square root of 5, all divided by 2, just like this, okay? So there are actually 3 points of intersection on this line, okay? On the two graphs touching each other. They intersect when x is equal to 0, they intersect when x is equal to 1 plus root 5 over 2, and finally they intersect when x is equal to 1 minus root 5 over 2. These are the points at which the line y equals x squared and y equals x squared minus 1 touch each other, okay? So let's see, should we draw it? Maybe not. Let's just, to figure out our y values, because we also need our y values, don't we? Let's just substitute some things in. Now guys, just looking at it, I reckon the top one is going to be easier. Remember, we can substitute into either one because they have the same y coordinate, so it shouldn't matter which equation we use. I think the top one is going to be a bit easier. So all we need to do to get our y values is square the 3 answers. We just need to square them because this is the x coordinate squared gives us our y. Okay. So one coordinate is going to be 0 because this is our x equals 0. 0 squared, what's 0 squared? It's just 0. So one coordinate is 0, 0. So these guys intersect each other at the origin. Okay. Another one is going to be, let's use this guy. It's going to be 1 plus root 5 over 2. And then we need to square that. So we're going to go into our calculator. We get 1 plus root 5 over 2. And we square the entire thing. And we end up with 3 plus root 5 over 2. just like that, okay? So that's another point of intersection. The final point of intersection is 1 minus root 5 over 2. And we're going to square that as well. And we end up with 3 minus root 5. Oh, that does not look too good as a 5. 3 minus root 5 over 2. So these are the 3 points of intersection of the lines y equals x squared and y equals x times x squared minus 1, okay? These are your answers. These are basically the solutions to a simultaneous equation. If you had this and this, if this was a simultaneous equation, these would be your answers. And remember, you can't overlap them. You can't say x is 0, y is, 3 minus root 5 over 2. Doesn't work like that because these are coordinate pairs, which means they have to come like this, or like this. You can't mix and match them. Those are the answers. So if you drew these on a graph, that is what you would get. You would essentially get, these are the points at which they intersect each other, okay? All the questions are exactly like that. You just need to set them equal to each other, do a bunch of basically simultaneous equations. So if you're not strong on simultaneous equations, practicing this could definitely help you, and vice versa. If you're not strong on this, maybe practice some simultaneous equations, and if you're strong at simultaneous equations, then you should be strong at this as well, because it's the exact same principle. Anyway guys, thanks so much for watching. I'll see you in the next video. Cheers.